Ancient frozen life beneath the Antarctic ice. Deep beneath the vast and seemingly eternal layers of Antarctic ice, scientists have uncovered traces of life that defy both imagination and established science. Hidden within crystalline ice cores, these remnants are not the echoes of recent ice ages but signs of organisms that may date back more than 500 million years to an era when Earth itself was undergoing immense transformation. Discovering evidence of life predating humanity by such a vast span compels researchers to rethink what endurance and survival truly mean in the planet's harshest realms. The ice cores extracted from the depths of the East Antarctic Plateau serve as frozen chronicles of Earth's climate. Each layer of compacted snow locks away air particles, dust, and minute biological materials, forming an unbroken archive stretching across eons. In recent years, analyses of these cores have revealed astonishing discoveries, traces of microorganisms so well preserved that fragments of their genetic material remain readable. Scientists examining them have found signs of faint metabolic activity and intricate cell structures, suggesting survival techniques far beyond prior understanding. How could such life persist through ages entombed in ice so isolating and severe? Dating techniques point to staggering antiquity. Radiometric analysis of the surrounding ice and sediment indicates that some of these microbes trace their ancestry to the early Paleozoic era, a time when primitive animals thrived in oceans, continents drifted, and complex ecosystems were just emerging. If verified, this would mean that certain forms of life have survived for 500 million years enduring catastrophic climate shifts. Meteor strikes and mass extinctions only to be sealed within the ice, still intact but separated from the surface world. The implications stretch far beyond biology. For evolutionary scientists, these ancient microorganisms could represent living genetic archives revealing the earliest experiments of evolution. They may hold secrets to how primitive organisms adapted to drastic environmental shifts in temperature, oxygen, and salinity. Their resilience could illuminate the outer boundaries of life itself and raise new questions about whether similar endurance could exist beyond Earth. If microbes can remain viable in Antarctica's frozen isolation for such inconceivable time spans, might not life also survive on icy moons like Europa or Enceladus? Yet the puzzle remains: how can organisms remain viable after such unimaginable confinement? Laboratory studies suggest that some microbes enter extreme dormancy, suspending metabolism to nearly zero while preserving their structures. Specialized proteins, cellular antifreeze compounds, and self-repairing DNA mechanisms may aid their survival, but scientists suspect other unknown processes operate quietly within the ice, ensuring life persists where it should not. The ice performs dual roles, both protector and preserver. Shielded within its depths, microorganisms are spared from radiation, oxidation, and physical damage. Layer upon layer of snow compresses into dense ice, sealing the cells in a remarkably stable habitat untouched by surface turmoil. The deeper the ice, the older and better protected the specimens become. Antarctica's frozen expanse thus transforms from barren desert into a natural time capsule, a frozen library chronicling life that endured planetary chaos. Around 500 million years ago, during the Cambrian explosion, Earth experienced an unparalleled surge in biological diversity. Seas brimmed with evolving creatures, yet it appears that some microbial lineages survived beyond that age of flourishing life. Ultimately trapped as the continent cooled, could these ancient microbes be the last direct descendants of primordial ecosystems, offering a biological bridge to a vanished world? They challenge our understanding of adaptability and reveal how even the smallest organisms can withstand planetary change. Scientific efforts to study these organisms proceed with meticulous caution to avoid contamination. Researchers extract ice cores under sterile conditions, preserving authenticity. Molecular biologists sequence fragments of DNA, analyze biochemical pathways, and search for subtle indicators of metabolic persistence. But questions multiply. Do these entities still reproduce slowly beneath the ice? Are they truly dormant, or do they interact chemically in ways we cannot yet detect? Beyond the scientific intrigue lies profound symbolism. Within the coldest continent on Earth, life continues to whisper from its frozen depths, reminding humanity that existence finds a way even in desolation. These microorganisms embody patience, resilience, and continuity. They reveal a hidden frozen world where time is measured not in centuries but in hundreds of millions of years, where microscopic life waits quietly beneath a white sky for discovery. As scientists continue to probe deeper into the Antarctic ice, each new finding adds to the mystery. How much life still lies concealed in this frozen vault? What lessons might these ancient beings impart about endurance, evolution, and the very origins of life? And what other secrets might still sleep within the ice, awaiting the moment when humanity finally listens to their silent testimony? The story of life that refuses to yield to time remains one of Antarctica's greatest and most haunting enigmas. Cosmic fragments beneath the Antarctic ice. Amid the shimmering depths of Antarctica's frozen caverns where ancient light refracts through crystal structures preserved for ages, the gaze of science turns upward toward remnants of distant worlds that have journeyed across the cosmos to rest upon this icy expanse. Meteorites born from shattered asteroids and cataclysmic planetary impacts have fallen to Earth for billions of years, yet nowhere else has the planet offered a more perfect vault for these celestial relics than Antarctica. Within its vast white wilderness and sculpted ice, humanity finds both evidence of the universe beyond and enigmas that remain unresolved. The first meteorites discovered on the continent during the 1960s revealed a hidden natural archive. Unlike temperate regions where stones quickly erode or vanish beneath vegetation, Antarctica's glacial plains preserve them in pristine condition. Dark fragments scattered across bright ice are easily visible, and glacial movement slowly gathers them into concentrated fields known as meteorite stranding zones. Some of these extraterrestrial stones have lain untouched for tens of thousands of years, preserving records of cosmic events that occurred long before the dawn of humankind. What makes these finds even more compelling is their astonishing diversity. Scientists have identified thousands of meteorites ranging from metallic iron masses to carbon-rich chondrites containing primitive organic materials. A few originate from Mars, others from the Moon, and still more from the asteroid belt between Mars and Jupiter. Each piece bears unique chemical and structural codes revealing its birthplace and the ancient forces that shaped it. Together they form a library of planetary creation, cosmic collisions, and the early history of the solar system. Some carbon-based specimens even raise the question of whether the seeds of life itself might have been carried to Earth within such celestial messengers. Antarctica's extreme environment deepens the intrigue. Relentless winds and glacial motion transport these stones across the continent, sometimes polishing their surfaces or concentrating them in mysterious geometric arrangements that appear almost deliberate. Scientists largely attribute these patterns to the slow movement of ice over buried ridges, yet the precision and consistency of certain clusters continue to provoke curiosity. Are these alignments purely the result of natural forces, or could undiscovered processes within the ice be shaping their distribution? The historical record adds another layer of wonder. Among the most remarkable finds, the Yamato meteorites of East Antarctica contain some of the oldest known extraterrestrial material, dating back over 4 billion years. Their journey from deep space to this frozen land prompts questions about the immense events that cast them through the void and the cosmic mechanisms that delivered them here. Could Antarctica itself act as a silent collector, gathering fragments of the solar system over endless ages, preserving them for the few who venture to uncover them? Each meteorite tells a story of violence and transformation. Some reveal scorch marks and molten textures from their fiery passage through Earth's atmosphere. Others show shock veins and deformations that record the brutal impacts which shattered planets and moons long ago. Certain samples exhibit chemical compositions so rare they challenge established theories of planetary evolution, hinting that our solar system may be far more complex and diverse than once believed. Within their mineral matrices might lie traces of unknown reactions or even early prebiotic chemistry, offering tantalizing glimpses of how life could arise beyond Earth. Even after decades of exploration, Antarctica continues to yield surprises. Every field season brings new discoveries, sometimes in areas thought thoroughly examined. Alongside common stony and iron meteorites, researchers uncover rare chondrites and specimens with unusual isotopic fingerprints, forcing scientists to reconsider how and where these stones began their cosmic journeys. The frozen landscape becomes a timeless stage where celestial history and geological motion intersect, revealing pieces of other worlds through the quiet unfolding of time. The questions extend beyond space into the history of Earth itself. Could past meteorite impacts have altered climate-triggered extinctions or even delivered the molecular foundations of life to our young planet? Some scientists explore whether organic compounds within these cosmic fragments may have seeded primitive microorganisms, connecting the heavens above with the hidden microbial life entombed beneath Antarctic ice. If such materials could endure the frozen vacuum of space and remain viable within ice for millennia, what might that suggest about the endurance of life elsewhere across the universe? Against the blinding white horizon, each dark meteorite stands as a messenger from the stars, a traveler across immeasurable distances and epochs, arriving in a place where human footprints are fleeting, yet curiosity endures. Their stories encompass origin, trajectory, and transformation, and they remind us that Earth itself is part of a greater celestial continuum. As we trace these scattered remnants across the continent, questions multiply. How many more lie buried unseen beneath the ice? What revelations about our solar system and the rise of life might they still hold? Could some concealed phenomena beyond present understanding in the stillness of Antarctica, the cosmos, and the Earth meet, merging past and present into one enduring mystery awaiting those bold enough to seek it?